right? But we're going to get into the nitty gritty on this stuff here. So let me introduce myself. My name is Jerry Flanick. I'm from Cleveland, Ohio. Just a quick little brief introduction. I started out in the building trades, I don't know, like several decades ago. Started out in the mechanical trades in Cleveland, Ohio. I did primarily heavy commercial industrial work. I was a pipe fitter at a local 120 in Cleveland, Ohio. Still hold my card. I've been a member for about 38 years. Rough and tumble world. I was coming up through the building trades and I got injured on a job, kind of messed up my arms pretty bad. And I said to myself, you know what, I got to keep my hand in the business. So what I did was I actually went into business for myself. I did electrical, mechanical, and I started to dabble into some building construction later in my career. At the same time, I started going to night school. I said, you know what, these architects and engineers, I could do this stuff. This isn't hard. And I went back to school and I walked away with 3 engineering degrees. I'll tell you, I love education. It's fantastic. One of my professors actually grabbed me and I came back to one of the colleges that I got my first degree in. And I've been teaching there for about 16 years as an adjunct faculty instructor in the civil and the electrical engineering departments. That was my beginning. I ended up talking to a person many years ago that when the ICC first came into fruition, if you will, to teach for the ICC, and I've been doing that for about 16 years. So that's my bag. I love education. I love construction and engineering. What do I do today? Well, after being a building official for 16 years, went into my own business again, and I'm a consulting engineer and do a whole lot of stuff. I'm a code expert in all disciplines. I represent building departments, architects, engineers, and attorneys call me once in a while to weigh in on a forensic scoping once in a while. I help them people out as well. So that's my bag. I'm into all kinds of stuff. And guess what? I go back to my roots, this piping stuff, mechanical and plumbing. I guarantee you're going to have a good couple of days. We're going to learn a lot. So that's a little bit about me. Let me find out who you are. We don't have a very big class here today, so I have everybody up on the screen here. And what I'm going to do is I'm just going to kind of roll this thing in here like this. And I see Edwin up there. Edwin, please unmute yourself. Tell me who you are and what you do. We'll kind of go through this quickly here.
My name is Edwin Harding. I work with Florence County in South Carolina. Right now, I'm combination building inspector, which is what I enjoy. I've been building official and plans examiner, but yeah, I like going in the field and inspecting the building. So I retired and then came back to work.
Okay, good. Welcome, Edwin. Don, good morning.
Good morning, everybody. I am a third-party private company and work for 3 cities out here, just south of Seattle, Washington. And I'm a building official, retired 2 times. Was a chief building official of Washington, D.C. for a few years. So we're now involved in inspecting all of the rental housing in the area, and that's quite an experience because it's kind of like new construction, but a different world. So that's kind of the scoop.
Yeah, well, great. Welcome, Don. Jamie, good morning.
Good morning. How are you?
Great.
I am a fully certified combination inspector who has chosen to come back into the office and work as a permit tech. My strengths are in quality control. I worked for about 10 cities here in the Bay Area in Northern California, currently working about 17 miles north of San Francisco in Knoll, very small city, and had an opportunity to actually be an inspector for NASA on a very large project for NASA. So I'd have to say throughout my career, that was probably the most fascinating job I had.
Great. Well, welcome, Jamie. Carl, good morning, Carl.
Good morning. How are you?
Hey, good.
Hi, I'm I've been a building contractor for the last 26 years or so, and then decided to actually get on the other side of the fence because of being tore up, working.
Yeah, right.
So injury wise and stuff. So now I'm working as a building inspector for the city of Globe in Arizona.
Great, great.
With my certifications.
Excellent. Welcome, Carl. Melissa, good morning.
Good morning. My name is Melissa Gentry. I work for the city of Pleasant Hill, Missouri, which is south of Kansas City, Missouri. I'm currently our development coordinator and building inspector.
Okay, great. Welcome, welcome. Carla, good morning. Okay, no audio.
No, I just don't know how to press buttons.
Oh, there you go.
So
That's
I'm
'cause you're
Carla
on the
Umland.
beach.
Huh? What's that?
That's because you're on the beach. Beautiful background there.
Thank you. That's
Yeah.
my hometown of Belize. That's on Key Cocker.
Ah.
Where my family is from. So let's see. I'm from Kansas City, Missouri. My jurisdiction is unincorporated Clay County. So I'm responsible for all the areas of Clay County that aren't outside of townships
Right.
and other jurisdictions such as that. I keep going a little bit fuzzy because I just realized I've got a fourth township that they've put on my plate along with the unincorporated. So not quite all of the townships are off my plate. Very busy. It's a, let's see, one-person show. So plan review, permitting, inspections. I do
Okay.
all the inspections, MEP, structural, commercial, residential.
Wow, great.
Yeah, I've been, my background is I've worked with corporate for 15 years, specialized in fire protection, industrial
Yeah.
engineering, point of contact for all of responding outside government entities for a hazardous chemical site. So that's what my specialty is in, is hazardous occupancies.
Okay,
And
sounds
also
like you have quite a bit of experience there.
Yeah.
Hopefully we can teach you something in plumbing and mechanical, maybe fill a couple of voids, you know? That's great. Great, well-rounded.
I've chased a lot of pipe in my days. And I've actually done pipe fitting and all kinds of stuff. I'm a hands-on
Right.
type of person. So anyway, and a
Excellent.
code consultant for another number of years. So now this is what I do. I'm an inspector.
Good for you. Well, welcome, Carla. Thank you for the introduction. Good morning, Francisco. Good morning. Hi, Francisco.
You might have to specify. There's two of us here.
Oh, there is. Oh, I'm sorry. Francisco R. Francisco R.
Let
Take
me
the stage.
let me go by Frank. That way
Frank.
you can yeah. It's usually how they call me.
Yep, gotcha.
Okay.
We're
'Cause
gonna.
there's another Francisco like he mentioned before. Anyways, I've been working with the state of Colorado Division of Housing as a building inspector. 15 years prior to that, I used to work for 2 different manufactured facilities, building modulars, hot homes. Been in the construction business for more than 30 years. But like I
Great.
said, you know, right now I've been working with the state. Is here to learn more. Get my CEUs.
Okay, great. Well, welcome. Thank you, Frank. Boudreaux.
Boudreaux, yeah, it's Rhett Boudreaux. I work for the state of Louisiana. I work for one of the state agencies. We inspect HUD properties, HUD different programs, tax credits, home credits, CBDG credits, and everything for HUD. I'm just starting in the ICC certification here. I'm learning the book. I was listening to Ms. Jamie and everybody over there telling me what to do and how to do it. So I'm excited to learn some new things.
Great. I'll tell you what, these institutes are fantastic, Boudreaux, and you really learn a lot how to navigate through the books. But yeah, welcome. Great. You're in the right spot. Christopher, good morning. Great. Never give up, Chris. Welcome to class. Excellent. Daniel, good morning.
Morning. I've been a mason for 19 years, and I'm trying to make a change too. So that's what I'm here for, to get certified.
Great, great. Good career change. Good morning, Harold. How are you?
Doing good. I'm here in Wagner, Oklahoma. I'm the Wagner County Building Inspector. I travel all over the county, which is about 600 square miles. And we're just south and east of Tulsa. So a lot of building going on here. Keeps me busy.
Yeah, good, good. Staying
I've been
busy.
about 40 years in the building industry, been building or in it all my life.
Excellent. Welcome, Harold.
Thank you.
And Antonio, good morning. Good morning, Antonio.
Good morning. I'm Antonio. I work for the city of Rio Grande City. We're a small town near the border of Mexico. I'm the city building inspector. I'm a code enforcement officer, and also I'm a planner.
Okay, great. Welcome. Thanks for being here.
Thank you.
We have a gentleman, N. Prosh.
Yeah, Nathan Prush.
Prush.
I'm the city engineer for Portsmouth, Ohio. So I have my interim residential building official certification, so I'm going for my full certification.
Okay, welcome, welcome. So yeah, you're an Ohio guy, just like me. Yeah, I know all about the Board of Building Standards here in Ohio. Yeah, good. Welcome, Nathan.
Thank you.
Yeah. Fabian, good morning. Fabian, good morning.
Good morning.
Yeah.
I'm Fabian Rodriguez from the city of Elsa, deep in the South Texas, by the border as well, next to Rio Grande. Our fellow companion just checked in. I'm the planning coordinator. I do inspections, a little bit of code enforcement as well. And I'm new to the field. I've been doing this job for a year. My background is in law enforcement, so I'm switching over to civilian side.
Okay, great. Good career change. Good morning, John Baxter. Good morning.
Hey, good morning. I'm John Baxter. I work for the city of Thomaston, Georgia, a small town in Georgia. My title is code enforcement officer, but I assist in everything in the building department.
Great, great. Learn all you can in them building departments, that's for sure. Welcome, John. Good morning, Ronald. Good morning, Ronald.
Good morning. My name is Ronald Sidney. Currently, I'm the chief inspector here at Harris County in Houston, Texas, for the permits department.
Okay, great. Welcome to class. We have Antonio, Boudreaux, Carl, Chris Rose. Good morning.
Good morning, sir. How you doing?
Great.
Yeah, my name's Chris Rose. I'm here in California. I'm working in Sonoma County. I'm a consultant who we've set up a shop that takes care of all the wildfire recovery for the area. And so I manage that in the capacity of a building official. Background is Marine Corps engineer, developer, and assistant city engineer.
Great.
So
great.
Here to learn a little bit more.
Okay, great. Thanks, Chris. Welcome. Doug Groth, good morning. Groth.
Good morning. My name is Doug Groth. I'm a building inspector with the Village of Bayville in New York and a certified floodplain manager.
Okay, great. Welcome, Doug. Paul Caraway. Good morning, Paul.
Good morning, Paul Caraway. I'm in Washington, D.C., and I'm a building inspector for the Department of Regulatory Affairs.
All right. Welcome, Paul. Welcome. Brandon. Good morning, Brandon. Brandon Robbins. Good morning. All right. Brandon may be getting a cup of coffee. Owl. Good morning, Aus.
Yes, good morning. My name is Oz, and I'm a development inspector for the Harris County, and we're here to get this certification going.
All right, great. Great, welcome. Kay Johnson. Kay Johnson, good morning.
Good morning. My name is Kevin Johnson. I'm here in Houston, Texas. I work for Harris County, and I'm one of the development inspectors.
All right, welcome. Thank you. Thank you. Scott Gilbert, good morning.
Morning. I'm a building and code enforcement official for the town of Glen Rock in Glen Rock, Wyoming.
All right, Scott, welcome. Sierra, good morning.
Good morning. I'm Sierra. I'm an executive assistant for a construction company and just trying to learn some more stuff.
Thanks for being here, Sierra. It's nice that we have a representative, of course, from construction. I think that's where most of us came from prior to maybe getting into this career, but good morning. You're in for a nice class over the next couple of days. Jason's iPad, I see on my screen. Jason's iPad. Good morning, Jason.
Good morning. My name is Jason McClinton, and I am a one-stop shop for planning, building, inspection, official, everything for the town of Summerdale in Summerdale, Alabama.
Great. You know what? When we're like the one-person operation, unbelievable. You're like the janitor. You got to do the cleanup. You got to be the architect, the engineer, the building official, the psychologist. I'll go on and on. You know what I'm talking about.
And I'm brand new to the trade, so
oh man. Well,
let's throw a kink in the system as well. So
that's okay. You know what? Learn all you can. Learn the good, the bad, and the ugly, and evaluate and move on. That's the key to this game here. Rashana. Good morning, Rashana.
Good morning. Hi, I'm Rashana. I'm here in Washington, D.C., and I work for a third-party company. I'm the manager of inspections, and I'm looking to just jump into learning building inspections.
Great. You're in the right spot all week long. I bet you learned a lot from John Gibson and the electrical guy yesterday, and fantastic.
Definitely. Thank you.
Great. Betty Davis. Betty Davis. Good morning.
Good morning. My name is Betty Davis. I'm a development inspector with Harris County in Houston, Texas.
Great. Welcome. Oscar. Good morning, Oscar.
Morning, y'all. I'm Oscar, development investigator out here in Harris County.
All right. Welcome, Oscar. Susanna. Susanna, good morning.
Hi, good morning.
Okay, welcome, Susan. All right. Jerry Lee, good morning, Jerry.
Good morning. Good morning. I'm one of the lead inspectors for Harris County. Good morning.
Yeah, it sounds like the audio is kind of getting all scrambled up there, Jerry. Little audio. All right. We'll check back with you in a little bit, Jerry.
My internet is late.
All right. And then let's see, R.E. Steve A. is the last one, I believe, or?
Hello, my name is Ruben Esteva.
Ruben.
Houston, Texas. I'm a development inspector for Harris County.
Okay, great, welcome. Let me think here. I think we have everybody. If I missed anybody, please chime in, and then we're going to get started here. All right. All in favor, say aye. Aye. Let's get moving along. What do you think? I like it. How about you?
Aye.
All right. So let's talk about what you should have in hand. You have in front of you this PowerPoint presentation. I'm going to go back to the very first screen here. This is going to be our focus for the day. And you also should have, I'm going to swing this on the front screen. Can you see this? Give me a thumbs up or nod your head. Yes, I can. Can you see this up on the screen? Yes, thank you very much. This is your workbook that we're going to discuss over the day here today. And this is to be available to reference as we go along the PowerPoint presentation, okay? In addition, ladies and gentlemen, I have available in front of me the 2018 International Residential Code. You should have a copy of this. If you don't worry about it. I have the code book right in front of me, and we're going to talk about this code book. I'm going to introduce it to you, not the whole thing, because you've been into this thing over the past 3 days. So I'm going to just focus on the plumbing part today and the mechanical part tomorrow. So these are our materials for the day. And without anything further, let's get started. I'm excited. How about you? So the goal of this seminar is to help you understand more about plumbing, help you perform a better plumbing inspection. And I got to tell you, if you're a plans examiner, an architect, or an engineer, believe me, you're going to learn a lot from this class as well as we go through this thing to enable you to better perform your jobs as well. So the key to this whole seminar, ladies and gentlemen, is to understand how we communicate in plumbing, how we talk in mechanical and plumbing discipline. I got to tell you, ladies and gentlemen, the terms, the words, the language that's in our plumbing code is something that we need to understand, because each discipline has its own language. Would you agree with that, ladies and gentlemen? Each discipline has its own language. I don't care if it's structural, civil, mechanical, fuel gas, electrical. We need to understand this. And if we don't, then maybe there's a definition embedded somewhere in our building code that we can understand, maybe a term or a few terms. We're going to expand this out and describe the plumbing inspection process, not only the inspection process, but the system that we call plumbing system, whether it's a water supply, water distribution, or drain, waste, and vent in a step-by-step fashion. I'll help you understand the concepts and the specific requirements that are in this particular code. Well, here it is right here. We're going to go over this systematically. We're going to help you understand and be better able to do the following, right? Determine if a given residential dwelling complies with the plumbing part of the residential code. Understand, we're looking at chapters 25 through 33 of the IRC. The edition is the 2018 version, right? We will definitely locate and apply plumbing code requirements. Now, I'm going to ask you a question, ladies and gentlemen. You ready for this question? It's no pop quiz or anything. Does anybody have experience with plumbing? Raise your hand. Give me a nod. Yes or no, or maybe. Fantastic. This class is tailored towards everybody. I'm going to start out basic, but I promise you, if you're a veteran piping kind of person or plumbing kind of person, I'm going to get more complex as the day gets longer. I promise you. I'll challenge everybody in this class. Now, where I want to go right now is I want to bring up my code book real quick here, and then I'm going to go over the handout, which is your workbook. Now, here's the plumbing code. You've been in this code for the past 3 days, so you know what? I'm not going to bore you with all those other details for building and electrical, because that's not why we're here today, right? We're here today to talk about the plumbing, right? So right away, if I'm kind of looking at plumbing, well, the first thing that I want to do here is I want to go to the table of contents here, and I want to go all the way to chapter 25, because that's where we begin here, right? Chapter 25. Look at this here. And I'm going to make this a little bit larger so we can see this here. Plumbing administration. Okay, it tells us a little bit about existing plumbing systems. I'm going to ask you another question. Do existing plumbing systems have the right to exist, ladies and gentlemen? Do they?
Yes.
Yes, they do, as long as they're maintained and they're in a safe operating condition, right, Don?
That's true.
Right? Can I add on to an existing plumbing system? Maybe I'm putting an addition on my house. Can I possibly add on to a plumbing system? Yes or no?
Yes.
Yes? No, or maybe, right? The answer is yes, if we have enough capacity left in the piping system, right? Absolutely, right? There is inspection and tests that we're going to take a look at, things of that nature, okay? But look at, this is in chapter 25. It's not till you get into chapter 26, you need to be familiar with this, ladies and gentlemen. General plumbing requirements are given to you right here in chapter 26, general. Like, gee, what do I need to know about structural and piping protection? If you bore through wood joist and things of that nature, John already covered that in the building code. I know he did, right? Chapter 5 for floors, right? Chapter 8 for ceilings, roof, things of that nature, penetrations, material evaluation, general kind of stuff. And this one right here, trenching and backfilling for underground piping systems. Chapter 27, we start to get more specific. Well, let me get back here. Chapter 27 is where we start to get more specific and talk about plumbing fixtures. Take a look at this here. You go to this section, ladies and gentlemen, for all the specific information based on not only fixtures, but fittings as well. Look at this. We've got a section here on tailpieces, slip joints. You're saying, Jerry, what the heck is all that stuff? Don't worry about it. I'll show you where that is when we get into the pretty pictures of the PowerPoint presentation. Look at the language here. We have a section here on what we call waste receptors. Don't let the language fool you, ladies and gentlemen. Understand, this is a device or a part of the piping system that receives waste. Call it a standpipe, call it a floor drain. The plumbing code calls it a waste receptor. Don't let the language fool you, ladies and gentlemen. Specifically, you're given showers, water closets, bathtubs. Wait a minute, water closet? What the heck is a water closet, ladies and gentlemen? Toilet. It's a toilet, right? But the code doesn't say toilet, it says water closet. That's the language. Things of that nature, a lavatory, fancy word for a bathroom sink. Don't let the language fool you, all right? Clothes washing machines, again, special stuff. Chapter 28, guess what? Water heaters. This is where we need to go for that appliance that actually produces hot water to distribute the hot water into the water distribution system on the hot water side. Well, fitting, look what comes after chapter 28. It's very well organized. We now talk about the water supply, not only the water supply, but also the distribution. These are two separate systems, and we have a whole bunch of stuff in chapter 29 geared towards materials, how to protect the potable water supply, things of that nature. It's not till you get into chapter 30 that we start to talk about the sanitary drainage system, the drain and waste part of the system. We will talk about different types of piping, materials, different types of drainage systems, things throughout the day in chapter 30 that relate to the drainage and waste system. Chapter 31, I must say, is probably the most difficult part of not only the residential plumbing, but the commercial plumbing code. There are so many different types of venting systems that you can use, but it's very specific as to pipe sizes, grading, whether I need one vent or multiple vents, things of that nature. We will have the opportunity towards the end of the day here. I'll show you how to design and install some of these specific venting systems so you completely understand the demand and the type of venting system to possibly use, not only in practice, but also as a plans examiner and a plumbing inspector. Chapter 32, guess what? Traps. I call this the safety valve. We're going to talk about this up front this morning as well. The safety valve, yeah, it's a place where water hangs out in a piece of pipe that's 180 degree. It looks like a big U, like a U-tube manometer kind of a thing. And it protects the occupants of the house from migration of sewer gases that may migrate into the house. We call it a trap. It's a water-filled trap. Chapter 33, storm drainage, and we end it on chapter 33. So understand, just looking at the table of contents, Man, oh man, we have a lot of stuff in here that is plumbing related. Given that, I will go over our workbook with you. The workbook is designed exactly the same way as your first two classes that you took with us earlier this week. You're going to find that the content layout is exactly the same. If you go to the table of contents here, right? Look at this. We'll go through the overview. We'll go through the process. What we have here is a bunch of tasks. And at the end of each task is a really nice summary type of a checklist for you. You can actually use in the field or use as part of a plan review process or even a study guide, ladies and gentlemen, if you're planning to take ICC examinations. So we will locate everything and reference this along the way. Now, what I'd like you to do is turn to the very first page. I have it over here on the left-hand side. It's called the overview. I already gave us the description of what we're into. You know what the goal is. You know what the objectives are. The target audience is, guess what? Everybody in the virtual classroom here. Now, these icons here, you saw these earlier with John. Refer to your code book, for example. This is your key in the upper left-hand side location of the slides to say, okay, this is what we're going to be doing, maybe an activity. Refer to your code book if you have one. This is a great opportunity for you to engage and maybe mark up your code book for some really good tips and tricks along the way on how to navigate through this plumbing section of your code. Now, ladies and gentlemen, I'm not here to sell you any books, believe me, but I'm a firm believer. You see this icon right here, this commentary? You should have a commentary based upon maybe the codes that you administer in your jurisdictions. I got to tell you, I represent a lot of jurisdictions today. I have a code commentary for every single I code that I engage with my clients. I feel that the code commentary gives me additional language and intents based on certain codes, things of that nature. Because I don't know, if you're like me, I could read a code section and say, oh my gosh, what the heck did I just read? It doesn't make sense. You go to the code commentary, it may lighten or enlighten you of the content of that particular code. Now, these designations here, I'm sure John went over that with you. What I normally see is a bar that indicates new stuff in the code from the previous code edition, which was the 2015. The arrow, something has been deleted, right? Maybe like a table or an item that no longer needs to exist. The asterisk are relocation of items throughout the code as far as a reorganization. All right, now, this is your workbook. Follow along with the workbook in relation to this PowerPoint presentation, okay? So here's what we're going to do. What we have here is a flow chart. This flow chart gives us, up at the top, the rough-in inspection, okay? We'll start off with what we call the water service piping. The water service piping is, by example, let's say I have a city main running down the street in the right of way. Maybe I'm going to tap off of the city main underground and use that water supply pipe to enter into my house to supply water to my proposed new house that I'm going to build, right? That's called water supply, ladies and gentlemen, all right? The demarcation is the valve either inside or outside of the house at the house. The valve is the demarcation line. After the water supply valve, ladies and gentlemen, it turns into the water distribution piping. So first things first is maybe the water service piping. We need to inspect maybe underground. The next one is called building sewer piping. I'll show you this. I have diagrams and we'll go through this systematically. These are the two parts that we want to start with. We now branch off or diverge from this flow chart to a slab on grade project. That means I've got no basement, I've got no crawl space, it's a slab on grade house. Think about it. What needs to be inspected with respect to the plumbing systems? any type of water distribution that may be concealed by earth or concrete, perhaps, the slab, if you will. I need to look at this water distribution piping before it gets concealed. Any type of building drain piping under the slab needs to be inspected. Any part of the drain, waste, and vent piping would need to be inspected. If you go over to the crawl space or a basement project right here, if you have a basement floor or a crawl space, scratch coat of concrete, if you will, in the crawl space, we need to look at all drain, waste, and vent piping, etc., and water distribution piping. It's when we get to this point here that we call maybe this the second rough, if you will. That's the terminology that we use, or the slang that we use in the field. In other words, you've got your structure up. Let's say it's a wood framed house. You've got all the structure up, right? You're going in there and looking at the second rough before insulation and drywall, which is maybe the water distribution pipe, the hot and the cold water to the bathroom, to the kitchen, to the laundry room. We're looking at drain, waste, and vent piping throughout the house, prior to concealment, prior to insulation, prior to drywall, fixture layout dimensions. Is that toilet in the right spot, right? Or is it too close to the wall, right? There's fixture layout dimensions. In fact, you may have read that or went over that with John. I don't know. It's in chapter 3 as well. You get those fixture layouts. And then finally, we have the final inspection. We'll talk about the kitchen, bathroom, and utility. This is the flow chart. I'm excited. Let's begin. Here it is right here. Here's your systems right here. 5 plumbing systems: water service, building sewer, water distribution, drain, waste, and vent, and fixture layout. All right, I'm going to start out real basic with everybody. Let's look at this here. This is what we call an isometric drawing, okay? It's basically built off of a 30-degree angle right here from horizontal. You see the solid pipe here? This pipe right here, let's say it's buried underground. This is the water supply pipe, ladies and gentlemen. When it comes up into the house, we have what we call a water service valve. This is the demarcation. The outlet of the valve right here is called water distribution piping. This is the line in the sand, ladies and gentlemen, right? Water distribution pipe to the left. I'm sorry, water service pipe to the left, water distribution to the right. The solid line represents cold water. You could see the water distribution is distributed to what we have here is a laundry sink, right? I'll have a drop here, cold water. I'll run the cold water over to this, I don't know, this cylindrical shaped thing called the water heater. I need a cold water supply to the water heater. From that, I'm just going to go through the cold water distribution here. I'm going to go out to maybe what we have called a silcock, right? Or a hose bib on the outside of the house, cold water supply. Now that may be in a basement. I'll rise up to the first floor with my cold water, supply cold water to what appears to be a 2-compartment or a double bowl kitchen sink, right? Cold water only. I'll go over the hot water in a minute. Cold water rises up to the second floor, perhaps, into what we call a bathroom or a bathroom group. The cold water supplies this sink here that we call a lavatory or a bathroom lav. We move over and we feed cold water to the water closet, or as we call it in slang, the toilet. It moves over to the bathtub shower as well, cold water supply. Now, hot water distribution starts right here at the water heater. You see the dashed line? That's hot water supply. This is just graphical information for us. There's no pipe sizes, there's no materials. It's showing us the routing of the water distribution system. Hot water comes up. I feed a hot water supply to the laundry sink, to the kitchen sink, to the lavatory. Well, wait a minute. Do I feed hot water to the toilet, ladies and gentlemen? Do we normally feed hot water to the toilet? What do you think, Jamie, Carla, Francisco?
Only when you crisscross it.
What was that, Francisco?
I said only when you crisscross it.
Yeah, right.
I've seen
But
it.
not normally, no.
No, you don't, right? But I got to tell you, I got a funny story here, real life story. I was over in Japan, I don't know, a few years ago, and I'm staying at the Tokyo Hilton, right? So I get off the plane and we take a long bus ride to the Tokyo Hilton, and I had to go to the bathroom real bad. And guess what happened? I opened up the door in the bathroom, ladies and gentlemen. You with me? I see this thing. It looked like a toilet. But I got to tell you, on each side, it had controls on it, electronic controls. This thing looked like a Cadillac, ladies and gentlemen, with all those fancy controls. I was afraid to sit on this thing. So, what I did as I had to do a little inspection. I pushed a couple of buttons. Guess what happened? It had a nice hot water undercarriage on it. It had a blower on it. It had a sanitizer. This thing, it was wild. It actually had hot water pipe to it. This was a fancy toilet, man, I'll tell you that. But normally I don't see that kind of stuff where I'm from, I come from a working class family, But in general, the answer is no, you don't pipe hot water to the toilet, but you do pipe hot water to a fixture that we call a bidet, right? You'll pipe hot water to bidets. So I wanted to kind of spend a little bit of time just talking about that. So now we see it, hot water distribution, cold water distribution. Let me switch gears with you here. This is called a riser diagram. It tends to give you a little more information, but really not all the information you need, right? Like you need valves at every fixture to shut the water supply off, right? Shows a couple of them here. We still don't know the material type, but it kind of gives us a good graphical representation of the routing of the pipe as it appears in a flat two-dimensional type, if you will, type drawing. All right, a little more clarity. We look at the drain, waste, and vent system. This is where we want to talk about, again, the demarcation of the system. Do you see? I'm going to start down here at the very bottom. You see where my little cursor is here? My little laser pointer right here? If this is the house wall right here, do you see this vertical line here? And this pipe is allowed to extend, which it should, beyond the exterior wall. This pipe extends like 30 inches outside of the wall. This pipe is actually called the building drain, okay? And it extends 30 inches outside of the exterior wall. You know what it's called when it extends further than 30 inches outside the wall, like way down here to get to the city sewer? It's called the building sewer line, okay? And I'll show you that. There's definitions. So in the house, the lowest portion of the drainage system is classified as the building drain. Why am I telling you this? Because when you read the code, ladies and gentlemen, it speaks in those terms. You need to know where this piping is at based upon what they call that particular section of piping. Now, it's all gravity, right? Everything is going to drain by gravity as long as the pipes are pitched properly, and it would drain by gravity all the way through the building drainage system out to the building sewer system. Now, let's start up the chain here. Let's climb the ladder. You ready? We come up to this first fitting here. It looks like a T, I don't know, a CO. Is that like a commanding officer? What's a CO?
Clean out, yeah.
Clean out, right. Clean out. That's so you can gain access to the pipe to clear blockages. LT, is that a lieutenant? LT, where's my law enforcement people or my military people? No, it's not a lieutenant. What's a LT?
Laundry
LT.
tray. Laundry tray.
Laundry tray or laundry sink, yeah, not a big deal, right? So you have to understand these abbreviations or these acronyms, what they mean. How about this one? How about this one? Double bowl kitchen sink. Fantastic, right? So all the solid stuff is the drainage, right? All the solid line. A BT. Bathtub, right? WC. Water closet. Lavatory. Do you see something here in terms of, look at this, it's a trap. This is a trap right here. If you look under your laundry tray or your kitchen sink, you're bound to see a trap, right? I'll show you what a trap looks like. But wait a minute, when you get over here, I see a water closet. Why isn't the water closet showing a trap here?
Built in.
A water closet, yeah, the trap is inherent. It's cast into the fixture itself. You do not need an external trap for a water closet, period. End of story, okay? That's why we come up with a 90-degree right into a floor flange. All right, now, that's the drainage system. Gravity drainage, solid line all the way down. As long as the piping and the fittings are in the right orientation, it's going to work. As long as it's designed and built according to the plumbing code. The dashed lines here are what we call the vent. The vent. I guess I'll just ask a question. Well, why do we need a vent in our plumbing system? What's the importance of a venting system attached to the drainage system? Any idea?
Equalizing pressure.
Yeah.
Equalizing pressure.
Equalizing pressure. Yeah, we call it equilibrium, right? Equilibrium means kind of balance, right? Balance what? In this case, you're exactly right. We want the pressures to be balanced in the system, okay? And I'm going to talk a little bit about that as we go on a little bit further when I start to talk about traps. But for right now, you see this pipe right here, this vent pipe, it's going to go all the way up through the roof, and we're going to call this an air reference or an atmospheric reference. Atmospheric pressure, in our case, we're just going to say it's zero PSI, okay? It's going to be zero. In other words, atmospheric pressure, whether you realize it or not, has a force, and it actually has a force that it actually integrates into the plumbing system to provide a good reference for equilibrium, because we don't want any pressure differentials in our plumbing system because it'll affect our traps. I'll explain that a little bit later. Now, you have some definitions in your workbook here, and I want to go over a few of these definitions here with you before we move on. I'm going to make this a little bit bigger so we can go over this. There's our common terms right here. And as you see, you have a bunch of drawing symbols here. Now, some of these definitions are pretty simple. Some of them are kind of strange, though. This first one is called an air admittance valve, right? It's defined as the following: a one-way valve designed to allow air into the plumbing drainage system when a negative pressure develops in the piping. We just got done talking about what a vent is for. Well, sometimes in your plumbing system, you may be in an area where a vent maybe isn't practical. Like, I'll give you an example. If you have a kitchen, ladies and gentlemen, with an island countertop right in the middle of a kitchen, how economical is it to provide a vertical vent out of that island? You know, you don't want to do that. You know, you have a white or a dark colored pipe sticking up in the middle of the kitchen. That's not too cool. I'll put an air admittance valve underneath the cabinet by the sink, right? It's a special valve, and it's designed to open and close based upon the pressure in the system. That's exactly what we want, right? The air admittance valve. So it closes by gravity and it seals as well. Let me show you how this works. Look, here it is right here. Air admittance valve, right? You tie this to the venting portion of your trap side for the sinks. So take a look at this here. If I have a negative pressure, look what's happening here. Negative pressure in the piping system, what's going to happen? What you have here is a little diaphragm seat here. You see this? This is a diaphragm. This is your seat here. What's going to happen is this thing is like spring loaded. On a negative pressure, it's going to counteract and open up the diaphragm to allow air to come in to equalize the negative pressure in the system. Why we do this is because we don't want to lose the trap seal downstream of this device. I'll explain later, okay? But understand this is a pressure activated type of a valve, right? It operates off of negative pressure. It opens the valve and allows the atmospheric indoor air to come in, right, into the piping system. However, if I had a positive pressure in the piping system. I don't want that sewer gas, ladies and gentlemen, to come back and introduce itself into the environment. We want this valve to stay closed, and exactly that's what happened. You see, on a positive pressure, it's going to force that seat down, that diaphragm, and not allow any type of pressure to come into the building, okay? I'm going to go over a few more things here. Definition-wise, you have this little detail right here. It appears to be a laundry sink, but take a good look at this here as it relates to drainage. We have a definition called air break and air gap as it relates to drainage. This is how the code speaks to you. Well, what does it really mean? It means that if I've got a fixture drain like this thing coming off here, this vertical fixture drain here, and I pierce this flood level rim right where the floor drain is, if I go below that elevation, ladies and gentlemen, then we actually call this an air break. It's where you go below the flood level rim of the fixture. All right, the flood level rim. What are you talking about, Jerry? Hey, this is a trap here. This is a nice cross section of a floor drain and a trap, right? Here's the trap right here, and here's the floor drain, right? Now, if the trap got clogged, ladies and gentlemen, right, and my sink was on, the water couldn't flow around the trap and go down the drainage system. Do you agree? If this was plugged up right here, do you agree? All right, give me a thumbs up. You still with me, or you need a cup of coffee? Don't lose it on me yet. Don't lose it on me. All right. So if the sink is on, then what's going to happen? The trap's going to fill up, right? And it's going to spill over right at this point at the floor level. This is called the flood level rim. It's the same for a bathroom sink. It's the same for a kitchen sink. It's called the flood level rim. If a pipe pierces below that flood level rim, it's called an air break. Now, a safer type of drain is what we call an air break. An air break. This is where we elevate the fixture drain coming into a waste receptor by means of an air gap, right? So the whole room would have to flood right before it even entered this pipe to possibly contaminate a fixture or some other part of the piping system, an air break. This is a safer type of a drain. We have this particular graphic here. I want you to look at this here. As we looked at the original isometric drawing, you saw that in a drainage system, the solid lines were the wet part of the system. The dashed line was the dry venting part of the system. So as we look at the venting here, we say to ourselves, well, look at the different vents that we have here. If I come off of this bathtub trap here, and I made a statement and I said that every fixture requires a vent. I'll stay with that for now, but you'll find out later that we don't have to have a vent for every fixture if we do our venting right, or different types of venting. In this case, I pull a single individual vent up and come over until I get to this juncture right here. Wherever I have two or more vents that connect together, it becomes what we call a branch vent. Individual vents are just that. This is an individual vent coming over to this point. This is an individual vent coming from the trap to tie into a branch vent. Individual vent, individual vent. Once I connect two or more, it becomes the branch vent, okay? The stack vent, as indicated, is an extension of a soil or waste stack. Get this, above the highest horizontal drain connected to the stack. Well, okay, let's play the game. Here's my horizontal drain. It's the wet part, right? The stack vent attaches where? Above the highest horizontal drain in the building, right? There's no other wet portions tying into this particular vertical stack, is there? Absolutely not. It remains dry. It's called a stack vent, and it fits the definition accordingly. All right. Why do we go over this? Because when the plumbing code speaks, you have to understand what this stuff looks like. On the drainage portion, we need to understand two particular definitions that you have in your workbook here. Now, the first one is the following. Let's go the easiest one. It's called a fixture drain, singular, singular. It says the drain from the trap of a fixture to the junction of that drain with what? Any other drain pipe. Hey, that leaves it wide open, doesn't it? Watch this. Let me show you something here. The fixture drain is measured from the trap of the fixture. Here's my trap. Maybe this is a lavatory or a kitchen sink. Doesn't matter what it is. But I'm measuring it from the trap all the way to the connection of that drain with any other drain pipe. All right. So I say to myself, I come into a T here, a sanitary T. And if this is gravity, I'm going to be draining across and downward. And of course, I'll have a vent coming off the top of my sanitary T to vent this particular fixture. So it's this particular pipe that we call a fixture drain. Now, I made a statement a couple of slides ago, and I says, every fixture should be equipped with a dry vent. Well, if you look at this thing over here, this still fits the definition of a fixture drain, doesn't it? There's nothing about any kind of venting here. I could have a fixture drain attaching to another portion of the drain, right, at any part of the piping system. You always look at the drain, and then you say to yourself, do I require a vent off of this fixture? Sometimes we don't. Sometimes we don't require a vent, or maybe this horizontal pipe is the drain and the vent for the system. But it still fits the definition of fixture drain. We're only concerned about that particular pipe from the drain trap to another part of the piping, okay? Understand that. When we have multiple fixture drains that connect together, we call them a fixture branch, right? Kind of like the same thing as a vent, a branch vent, except now we're just talking about the drain, okay? This is where we have two or more fixtures that discharge into another portion of the drainage system. Horizontal drain is where we take the whole horizontal demand of the system and drain it into a stack, okay? That's called a horizontal drain. All right, beautiful. This is exactly where I want to be right now. I want to go over this, and then we're going to take a quick break, okay? But in order for me to go over this, I have a few slides to share with you, okay? There's a definition called trap seal, okay? If you read it, it'll be kind of confusing, but let me explain. The trap seal, we want equilibrium. How do we get equilibrium in a plumbing system? Well, you hit it on the head with the venting. We want some kind of pressure equalization so we don't have negative or positive pressure. If we have negative or positive pressure, how does that affect the trap? Well, ladies and gentlemen, here's your fixture trap right here. And within the trap, we have water that just lays in this 180-degree bend here. It's designed so we don't have a migration of sewer gas from the sewer side of the system, and it stops right here. If we didn't have any kind of a water elevation in this trap and it dried out, what would happen? The sewer gas would migrate and would go right up the fixture drain into the house. I guess this is where I ask you all a question. Has anybody ever in their lives smelled sewer gas before? Have you ever smelled that?
Yes.
All right. Well, what does it smell like, ladies and gentlemen? And be clean here. This is a clean class. What does it smell like?
Not good. Sulfur type smell, maybe.
Sewage.
It smells bad, doesn't it? It smells pungent. It's something that you never forget, right? But it's all part of you know, our system, our design, our function, right? Bottom line is we don't want that sewer gas coming into our house. So we got this water laying in this U-tube thing here that we call a trap. Why do I call it a U? Because it looks like a U, right? Right? Or call it a P-trap, whatever you want to call it. They call it a trap. Now, look what happens here. And I put this slide in here for a reason. If the atmosphere, maybe the pressure is pretty high inside the building, maybe due to the HVAC system or something, you got maybe a positive pressure built up in the building. What does that do to your trap here? Your trap is susceptible to pressure differentials, ladies and gentlemen. So the pressure inside the building may push the trap. In some cases, maybe completely out, right? How do we prevent that? By providing an air reference on this side right here that we call the vent, right? From the outside, right? So we want atmospheric pressure, and then we could say, oh, great, now I can overcome any type of positive pressures in the building and hopefully get to that point of equilibrium where we have the same elevation on each side of the trap, okay? Conversely, on the other side, we could have a positive pressure coming back this way and pushing the trap seal up the other way based on the pressure on the sewer side of the trap. So what does the code have to say about this? I'm going to bring this slide up. I'm taking care of a lot of business right now, so I don't have to do it later on. That's why we're talking about the traps here, ladies and gentlemen. I'm going to show you this thing here. You need to be understanding of these words here. Now, right here, here's the trap right here. The drain from the fixture comes down vertically this way. The water discharges through the trap, comes up, around, and then out the outlet, and then down the proverbial drain. That's how it works. More specifically, the water comes down through the dip of the trap. It rises up, ladies and gentlemen, and spills over the crown weir of the trap and goes and is graded towards and slopes down the outlet towards the other parts of the drainage system. Now, I sprinkled a couple of words in there, didn't I? This is called the top of the dip right here. Do you see this right here? You strike a line or a plane right across the top of the trap. That's called the top of the dip. At the same time, the point that it spills over, or the inflection point that it spills over, is what we call the crown weir. I'll strike another horizontal line or a plane this way. We call that the crown weir. It's the dimension between the top of the dip and the crown weir is what we call the trap seal, right? The trap seal. Manufacturers of manufactured traps like this, plastic traps, metal traps, they know this. They know what, Jerry? They know what the code says. Look what the code says. I'm in chapter 32 right now. We've jumped a bit, but that's okay. Section 3201.2. Each fixture trap shall have a liquid seal of not less than 2 inches and not more than 4 inches. So guess what? This seal has to be at least 2 inches, but not more than 4 inches. Fair enough. All right. Now, the traps, we got to protect them from kind of freezing, things of that nature, back siphonage, things of that nature. How do we do that? We maintain an air supply on the venting side. So when we look at this, ladies and gentlemen, this is all I want you to focus on is the trap seal and how this trap works here, okay? 2 inches and 4 inches, that's all we're looking at here, okay? One more slide and we'll take a break. This slide right here, you have another section here. So if you're taking notes like I would write these sections down. I'm in chapter 31, chapter 3105.3 section to be exact. It says crown vent. Jerry's been talking a lot about vents and traps. What is this for? It says a vent shall not be installed within 2 pipe diameters of the trap weir. Wait a minute. We just had that graphic, the slide before, that we know what a trap weir is. Instead, they called it a crown weir, but this is called the trap weir here, right there, at that point right there. So what does that have to do with this section in chapter 31? Well, it says, you know what? Anytime that you have a trap and you start to tie into a vent, the vent must be at least 2 pipe diameters beyond the trap weir. I'll explain. Consider a bathroom sink, a lavatory, right? You know, the hair buildup and debris and things that could possibly go down the drain. What's going to happen? As water flows, right? It's got a velocity. It's flowing down. It goes around the trap. And guess what happens? All that hair and debris is going to actually go upward here and cause a potential blockage in my vent that it's designed to provide air in the system so we have equilibrium, right? Again, hair, debris, water at a velocity comes around and it's going to back right up there if your vent is too close to the trap weir. Case in point, the code comes in and says you will be a minimum of 2 pipe diameters beyond the trap weir. So when all that debris and water comes down at a velocity as it comes around, it's got a chance to settle out and not block the entryway of my air reference that we call the dry vent. Does that make sense, ladies and gentlemen? Does that make sense? I say be the water, right? Remember that show Caddyshack, that movie a long time ago, Be the Ball? Well, this is be the water, right? Be the water. Bring it down. Don't block up my vent. Keep on going. All right, one more question before we go. It says 2 pipe diameters downstream. Do we know what the pipe diameters are in the plumbing code? Let me help you. If we talk about drainage, drain, waste, and vent, I'm going to give you the plumbing sizes here that we're going to deal with here. All right, you ready? Maybe you know. I'll give you the first pipe size that we're going to deal with. 1 1/4 pipe. What's the next size up from 1 1/4?
2 inches.
What's the next size up from 1 1/4?
1.5 inches.
1.5 inches. So we have 1 1/4, 1.5 inches. What's the next pipe size?
2
2
inches.
inches. Great, Melissa. Next pipe size after 2 inches?
3.
3.
There's a 2.5. 2.5.
2.5. Nobody uses 2.5. It's kind of rare, but they make
That's
it.
rare.
2.5. And then we have 3 inches. I'll go no higher than that because we're only residential. If we're commercial, I would go higher, but so we go from 1 1/4, 1.5 inches, 2 inches, 2.5 inches, and 3 inches. All right. Before we go on break, I'm going to ask you a question. I'm going to ask you to apply this code section to how many pipe diameters we need downstream. If I gave you a trap size right here, a trap size of 1 1/4 inches, 1 1/4 inches, right? 2 pipe diameters before the connection. What does that mean? How far away do I need to be then? If my
2.5.
trap size is 2 1/4.
2.5.
2.5. 2.5. And then I can put my T or my vent here and take off. That's how to work this thing. Okay. All right.
Jerry, I have a quick question.
Yeah, go ahead, Doug.
What if they're using larger than what's required? Is it 2 pipe diameters of the minimum required, or what they're actually using?
Well, let's back up. Larger than what's required. So you can't make the pipes too big because you're going to kind of get some settlement, especially if it's soil and stuff like that. So I'll be with you in a minute. So maybe over, what did you say, above, or give me an example, like 2 inches or something?
Well, so let's say 1 1/4 inches is required for this fixture, but they decide to use 1.5 inches.
Oh, okay. Yeah, I'm with you.
So then would it have to be, what would it then be, 3 inches, or the minimum required 2.5 if they're using the minimum required size?
No, it would be 3 inches.
It would be 3. Okay, so it's actual what they use. All right.
Yes, right. Yep. Yeah, good question. I like it. All right, so why don't we take a quick 10-minute break, get a cup of coffee, and then we'll be back. Quick 10-minute break.
Yeah, Jerry?
Yeah, go ahead, Don.
Yeah, well, just oversizing, of course, affects the velocity and you lose self-scouring. You're going to get into that
That's
later.
right. Yeah.
Yeah, all
Yeah.
right.
But there's some cases, Don, like when you do wet venting, you have to oversize the pipe for the wet venting anyway. So
Yeah.
Yeah, we'll go over that. Good comment, Don.
Hey, Jerry,
Yeah. Paul.
where is that figure? It says 3105. Where is it in the RBC? The IRBC.
The figure?
Yeah, the figure that you was just showing.
It's not in the code. The figure is not in the code. Let me get that.
So
up
that's
here. That's just in the PowerPoint, Paul.
okay. All
This
right.
figure right here, you see, this is from the code commentary. That's where you could find it. It's not in the code itself. This figure right here, that comes from the code commentary.
Okay. All right.
Okay. All right. All right. See you in about 10 minutes.